Hello everyone. In today's lecture, we are going to discuss about the hash functions. So hash functions are nothing but which helps to generate hash keys. We can generate a key for an element using hash function. So a good hash function should satisfy the two criterias. The first one is a hash function should generate the hash addresses such that all the keys are distributed as evenly as possible. Then second one is the computation of key by hash function should be simple. Okay, so these are the two criteria for the hash functions. So what are the different hash functions through which we can generate hash key for an element? The first one is division modulo method, or we can also call it as modulo division hashing. So it works with any list of size. If a list size is prime number, then fewer collisions are possible. So what is the formula we can use? That is h of k equal to k mod n, where n is the list of items, the size of the list, that is n. K is nothing but what? Key. So we are generating hash key for this particular element. K is nothing but what? An element or an item. So we are going to generate a key for an item or an element by using this function or by using this formula. For example, if the record is having these items 52, 68, 99, 84, so these items has to be replaced with hash key. So I want to give some hash keys for these items. So how we can give hash key for these items? Okay, so the size of the table is 10. The table size is 10. Okay, total table size is 10. So these are the items that needs to be placed into the table. So we need to generate the keys for these elements. How it is possible? This is possible by using the hash function. Okay, so 52 modulus of 10. 52 is nothing but what? It is an element or an item. Mod 10. 10 is nothing but total size. The table size is 10. Okay, so we'll get the key for the 52 is 2. So we have generated the key for this item, that is 52. Then 68. 68 mod 10. The table size is 10. Okay, 68 mod 10 is 8. So in the 8th place the 68 is going to store. The index position for the 68 is 8. Then 99 mod 10. So the index position will be 9. Then 84 modulus of 10. The index position will be 4. Okay, 84 is going to be stored in the 4th index. So this is with respect to modulo division method. So we have generated the keys for these items. The hash keys are generated for these 4 items. So they are going to store in the respective indexes. Then second one is mid square method. So in this method the key k is squared. Okay, a number in the middle of k square is selected by removing digits from both the ends. The key is squared and address is selected from the middle of square number. Okay, so for example, if you take, I want to generate the hash key for this item, that is 3101, and size of the table is 1000. The table size is 1000. So what is the key for this 3101? Where I need to place this 3101? At what index? At what index the 3101 has to be placed? So for that case we can use the mid square method. So we need to square this, we will get the value here. Then we need to consider only the middle value, middle 3 numbers. Okay, so 162 is the middle, so we need to consider only 3 digits. Okay, this is nothing but mid square method. Then the third one is folding method. So here consider the record which consists of this item. Okay, so it will be divided into, we need to divide this one into 3 digits, that is 1 2 4 6 5 5 and 1 2. Okay, so we need to partition these elements. Okay, then we need to add these elements. So we need to partition this element into 3 digits, that is 1 2 4 6 5 5 and 1 2. Then we need to add these all elements, so we'll get the value here. Okay, so this is with respect to what? Hash function. Then another one is there, that is fold shift function, or we can also call it as fold shift hashing. So the key value is divided into 2 parts whose size matches the size of the required address. Okay, so we need to divide into 3. The size of the required address is 3. Okay, we need to divide it by 3. Then we need to ignore the last digit and we'll get the key for that, that is 368. So address is given. 3 means we need to take only 3 digits. 2 means we need to take 2 digits. Okay, and another one is fold boundary hashing. So here the left and right numbers are folded on a fixed boundary between them and the center number. Okay, so as you can see, consider this number. First we need to make first 3 digits because the address size is 3. We need to reverse this, we will get 3 to 1, then 4 5 6 remains as it is, that is the middle number will not be changed, it remains as it is. So only we need to reverse the first 3 digits and the last 3 digits. Okay, that is 3 to 1, middle number remains as it is, and the last number will be 987. Add all these numbers and ignore the last digit. Sorry, the first digit will be removed. Why? Because we need to get only 3 digits, because the address size is 3. Okay, so we'll get h of k equal to 764. By removing 1, we'll get the 764. So first we need to add all these. First we need to reverse these first 3 digits. Then middle numbers remains as it is. Middle 3 numbers. And the last 3 digits also should be reversed. Add all the numbers and remove the first digits. So we'll get only 3 digit number. So this is a hash key for this number. This is the hash key for this particular number. Okay. So here we have taken address 3. Size of the required address is 3. Okay. So here also the size of the required address is 3. Okay. Here also it will be 3. Okay. So it depends on whatever the address we are going to choose it. So here the seed value, it is called as a seed value. The address is given, the address size is given. It is also called it as the seed value. Okay, here the address is given it as 2. Okay. So this is with respect to the hash function. The first function is nothing but division modulo method or modulo division method. So we are taking the modulus operator here. Okay, and we are taking considering the size. Okay. Mid square method in the sense, first we need to square the key element, or the item. Then we need to consider only the middle 3 digits. It also depends on what? The address size or a seed value. If the address size is given as it as 3, then we need to select only middle 3 digits, ignoring the first and the last digits. This is with respect to mid square method. And the folding method, it is also the same. First we need to consider the address size, that is the seed value. If the address size is given it as 3, then we need to partition the item into 3 digits and all the elements. So we'll get the total value. This is with respect to folding method. And fold shift hashing. So here also the size of the required address is given. Okay. Then we need to consider, if it is 3, then we need to partition into 3 digits. Then we need to add all these, then remove the first digit, whatever it may be, because it should be only of 3 digits. Okay. This is how we can create the hash key for the given items using the hash functions. I hope you all understood. Thank you.